This is Dr. Sajja Suneel from Data Science Department. Today we are going to discuss about principles of Internet of Things. In this principles of Internet of Things, I am going to discuss a topic from controlling hardware as well as controlling sensors in IoT industry. How these hardwares and IoT sensors are going to be controlled, and what is the use of controlling these hardware devices and sensors in this IoT system. How these are going to be helpful to us in a particular IoT system implementation. Let's have a look from this particular things which we are going to discuss today. The topics which I am going to discuss today was voltage sensor, ADC and DAC, which means analog to digital converter, digital to analog converter, and also temperature and humidity sensor, which is a combination of DHT11, right? These are the three different kinds of sensors which I am going to discuss with you in today's class. Along with these particular topics, we are going to know about these particular things in detail, what exactly the outcome was, what exactly from that particular topic which we are aimed for. All those things are going to be known to you, and have a look. What was the objective for this particular voltage sensor, ADC, DAC, and temperature and humidity sensor, and what was the outcome which we are going to get? All these things are going to be discussed in detail. Let's have a quick view about these particular topics in detail. As I told you, the main topic discussion was on controlling hardware and sensors, which we discussed for the past classes also. And have a look, guys. Controlling hardware, connecting LED sensors, as well as the relay sensors, as well as the speed control of DC motors, unipolar and bipolar, along with sensors, light sensors, temperature sensors, with thermostats. All these are the topics which we discussed in the previous classes. And in today's session, I am going to discuss with you about voltage sensor, ADC and DAC, temperature and humidity sensor, which is DHT11, which is also an alternative name for this particular sensor. Have a look, guys. After this session, I am going to discuss with you about some more sensors which are very helpful in IoT systems which are implemented in nowadays. Those are motion detection sensor, wireless Bluetooth sensors, level sensors, USB sensors, embedded sensors, along with this distance measurement by using ultrasound sensor. These are the different kinds of sensors which are going to be used by us in a IoT system. Let's have a look, guys, how this voltage sensor will function, how this ADC, analog to digital converter, and how DAC, digital to analog converter, and along with this temperature and humidity sensor. In the previous class, we have seen about temperature sensor, where we are going to measure the temperature levels, which comes under environmental section. And in this particular sensor, along with the temperature, humidity is also going to be measured with the help of this particular DHT11 sensor. Let's enter into the subject with a quick view. Have a look, guys. What exactly IoT? As I told you, Internet of Things. Here, every component which is connected through Internet will plays a crucial role. And these components are going to be used for gathering the information and for manipulating the data in physical world. How we are going to contribute with these particular sensors in our principles of IoT. Coming to the first one, voltage sensor. As I told you, voltage sensor will play a major role. What was the main intention of this voltage sensor was? What was the main objective? Here, we need to continuously monitor the health as well as the performance of devices by measuring the voltage levels in critical components such as batteries, powers, suppliers. Have a look. Critical components are batteries, power, suppliers. These are the things which we are going to have a view. For this particular purpose only, these voltage sensors are aimed. What was the outcome? Here, the outcome of this particular voltage sensor was, here we are going to enable the real-time data collection for preventive maintenance as well as optimizing the energy usage, and also for detecting potential malfunctions in a connected devices. As I told you, in principles of Internet of Things, lot of objects are connected to Internet. With that, we are going to enable the real data time collection for preventing the maintenance, and also we are optimizing the energy usage, and also for detecting the potential malfunctions which are going to happen automatically in any kind of IoT system. For that purpose, these voltage sensors are going to be known to us. And coming to the next one, ADC, as I told you, analog to digital converter. What was the main aim of using this analog to digital converter? Here, by using this ADC, I'm going to tell you confidently that this ADC is going to bridge the gap between the physical and digital worlds. Physical and digital worlds. How it is going to bridge the gap between physical and digital worlds? By converting the sensor data, which is voltage readings, into a format which is understandable by the digital devices. Like that, it is going to bridge the gap. What was the outcome of using this ADC? Here the outcome was, we are going to allow integration of various sensors such as temperature, pressure and light. These are the different kinds of sensors which are going to be allowed by variation the integration of various things in any kind of IoT ecosystem. And along with that, we are going to facilitate the data collection, and along with that, we are going to analyze the data. With that analysis, we are going to take a decision which is useful. And coming to the next factor, which is DAC. As I told you, DAC stands for digital to analog converter. Here, what was the main objective of DAC was, here we are going to enable two-way communication in IoT system. Basically, in IoT system, there will be one-way communication. Either we can contact to that particular objective, or it can contact to other objective. But in DAC, here the things are going to happen in a two-way communication system. Here we are going to translate the digital instructions from a central hub into physical actions. And what was the outcome? The outcome was, we are going to allow by controlling the actuators. The actuators are nothing but the lights, the valves, the motors which we are placing in a IoT system. By based on the sensor data or the user input, here we are going to create a particular feedback loop for automation purpose and also for remote control purpose in our smart homes, or else in industries, or else in connected environments. This was the advantage. As I told you, there are three different actuators such as light, valves, motor. Lights, smart lights, you can take a best example, digital to analog converter, where by detecting the motion, automatically the light is going to switch on and switch off. And by using walls, where saves like lockers, we can say it as, these walls are going to be placed with this particular DAC sensor. By detecting our fingerprint, the wall is going to be open automatically, and after the usage, again, if by placing the fingerprint, the wall is going to close automatically. And coming to motors, by detecting with the sensors, if the motor is going to start automatically and it is going to switch off automatically by based on the water level in the consistence motors. This is how these IoT devices are playing a major role in our advanced IoT systems. And coming to the next topic, which is our DHT11, which is temperature and humidity sensor. What was the main objective for this particular sensor usage? The main objective was, here we are going to gather the environmental data by based on temperature and humidity, which is crucial for various IoT applications. The things are the outcome which we are going to get by using this particular sensor was, here this sensor is going to provide us a real-time insights, a real-time inputs for applications such as smart agriculture, which is used for particularly optimization and irrigation purpose, and also for smart buildings, which are used for controlling, heating as well as cooling purposes. The smart building concept will play a major role in IoT system. This by using this smart building concept, it is going to control the heat as well as it is going to control the cooling levels, which is majorly used in areas like Antarctica, or else in the areas where we are really feel hot, automatically the room temperature is going to turn down into cool. The basic temperature is going to be maintained in such particular buildings. And coming to the next factor, which is remote patient monitoring. Nowadays, we are seeing most of the people are working environment. Both the most of the family members are working. Only grandparents are living in your respective homes. By using these particular devices, remote monitoring, remote patient monitoring, ensuring the comfortness as well as ensuring the safety environments to the things, the IoT system has been designed with the help of this temperature and humidity sensors. These are the advantages. I can confidently say by using these three components in a combination of our IoT technologies, which is going to enable the things such as connectivity, data acquisition, automation, and control. These are the three aspects which are going to be gathered by using these three sensors. Coming to the first one, which is connectivity. Connectivity will place a major role in IoT system. Why connectivity? Without connectivity, the system or the devices are going to or the devices are capable to function? No. Without connectivity, the devices are useless. I can say this word confidently. Why? Because with the connectivity only, the sensors are going to collect the data, and the ADC, which is analog to digital converter, is going to convert the transmission across multiple networks. You got it, guys? Yeah. And coming to the data acquisition, where we are going to continuously monitor the things, where with the sensor data, valuable insights are going to be calculated by using into the device health and environmental conditions. And coming to automation, and this data acquisition will place a major role. By based on the data gathered, we are going to analyze it, and we are going to take some decisions based on the analyzed data. And coming to the next factor, which is automation and control. Here in this automation and control, DAC is going to, DAC means digital to analog converter, which is going to translate the digital instructions into actions by allowing from remote control and automated response based on the sensor data. These are the advantages which we are going to get from these particular components. Now have a quick discussion about these three components in detail. Till now I have given only you an introduction about these particular components, and now we will see what exactly the voltage sensor was. You need to understand how this voltage sensor is going to be utilized with the help of some particular types of things which are inherited in it, such as resistive voltage devices, transformers. Along with that, before entering into this voltage sensors, you need to know what exactly the voltage sensor was. In the real time environment, this IoT, Internet of Things, this particular sensor is playing a major role. Where exactly? In monitoring and regulating the electrical systems. Exactly. In monitoring and regulating the electrical systems, this voltage sensor is playing a major role. Here, by using this, I can confidently say that what exactly the work you are going to perform and how can you are going to leverage them. All these things can be inherited into your IoT projects also. For that particular inheritance, you need to understand what exactly these voltage sensors are. These are the sensors, these are the devices which are going to detect and measure the electrical potentiality difference between 2 points in a circuit. Whenever they come into various types, each has its own working principle, such as resistive voltage dividers. That was the first thing. This was the sample circuit which uses resistors to create a voltage proportional to the input voltage, which is suitable for lower voltage ranges. And coming to transformer, I can say you one thing, where the transformers are going to be utilized in voltage sensor. Here we are going to use the high voltage sensor for AC, which is an alternative current, which is used for measuring the things, where we are isolating the circuit by stepping up, down or up. It depends on our requirement. And here, by based on the voltage factor, we need to take safety measures. We need to follow an accurate measurement whenever we are designing the things. And also, the next factor was Hall effect sensor, optocouplers. These are also inherited in this particular sensors. Whenever we are using this voltage sensor, Hall effect sensor, this was the sensor where it is going to be used for contactless, for detecting the changes in fields, and also for generating the current flow by enabling the voltage measurement without physically connected to the circuit. And coming to the optocouplers, where we are going to isolate the sensors. Basically, these optocouplers are having the highest voltage circuit which uses light and which is going to ensure the safety, and also which is going to accurate the measurements of AC voltage and DC voltage. For that particular purpose, these optocouplers are going to be utilized. And coming to the applications which are related to voltage sensors in IoT, have a look. Battery monitoring, solar power systems, smart grid management. First, we will discuss about these three in detail. Battery monitoring is one of the best application of this particular voltage sensor. Every IoT device will use this voltage sensor to track the battery health and also to trigger alerts for low battery or for replacement requirements. Right? For suppose there was a UPS connection which is there in your house. Whenever the UPS was low, it is going to indicate you with the help of this voltage sensor only that the battery power was low, kindly charge it. Or else, take your smart gadget which is more known to everyone. In your battery gadget, it is either it is going to give you an acknowledgement that the battery power was low or not, right? It was definitely give you an triggering alert. Then you automatically, if the charger was near to you, you are going to charge our concerned electronic gadget. That is how the battery monitoring is going to be done with the help of our voltage sensor. And coming to the next application, which is solar power management. In this solar power management, the monitoring of voltage output for solar panels is going to be very helpful for optimizing the energy production and also for identifying the potential issues. These are the two applications which we discussed now. And coming to the next application, which is a well known to everyone. Nowadays, everyone are showing interest towards smart grid management. In this smart grid management, voltage sensors in power grids are going to enable the real-time monitoring by allowing the efficient power distribution and also identifying the potential problems. These are the three different applications which are going to use our voltage sensor. And coming to the fourth application, which is industrial automation. In this industrial automation, we are going to monitor the voltage levels in machine language, and also we are going to process, which means we are going to help the provincial equipment and damagement, and also we ensures the optimal performance. And how this voltage sensor has to be integrated into your microcontrollers. First, we need to choose what exactly the sensor type was, which is determine the connection method, and which is whether the voltage sensor is resistively voltage device which interlace this analog voltage or analog to digital converter by using this microcontroller, and where exactly the transformers and also the Hall effect sensors may require additional amplification of signal conditioning circuits which are compatible for ADC, analog to digital converter. And by using optocouplers, we are going to provide a digital output by simplifying the integration with the microcontroller. These are the things how we need to integrate. And the next factor is how a microcontroller code for voltage sensor. We need to design a code which reads the voltage data, which is either the voltage is analog, either the voltage is digital, which is given by the sensor data. And depending on that sensor type, the calculations are going to be converted into the reading input, which is the actual voltage, or the voltage divider ratios, or the sensor specification. The voltage data can be used various properties. The first one is displaying voltage readings on a LCD or sending them to the cloud, which is a remote monitoring analysis. And coming to the second factor, which is triggering alarms or control actions based on voltage thresholds. And Safety considerations. What are the safety considerations? What exactly you need to take? We need to work with high voltages, which are very dangerous, which you guys are not comfortable with. So, consult a qualified electrician. Consult a qualified electrician for projects which involves main power. And we are always need to follow the safety precautions when working with electrical circuits, which includes proper insulation and avoiding overloaded circuits. And also we need to choose voltage sensors with appropriate voltage readings for your applications to ensure the safe operations in it. And by using this learning things, this will be might be very helpful to you for knowing more about voltage sensor. The first one is voltage sensor with Arduino and voltage measurements for IoT projects. These tutorials are going to helpful to you for knowing about this voltage sensor in detail. And also there are number of starter kits which are available in market for performing your microcontroller sometimes in voltage sensors, and which by performing these experiments we are very safe and controlled environment. You are allowing to perform your experiments with the microcontroller. And I can confidently say one thing: if you incorporated these voltage sensors in your projects, you are going to gain such an ability to monitor and manage the electrical systems most effectively. This opens doors to various applications from battery powered devices to complex industrial automations. With this, I can conclude one thing: voltage sensors, while prioritizing safety throughout the process, it is more helpful. And coming to the next factor, which is ADC and DC. ADC stands for analog to digital converter. DAC stands for digital to analog converter. In this principle, IoT, Internet of Things, as I told you, ADC and DAC, analog to digital converter and digital to analog converter, which plays a major role for bridging the gap between analog world and digital world of microcontrollers. How the functions and applications in IoT are. First, we discuss about ADC, which is analog to digital converter. In this analog to digital converter, a continuous analog signal. The signal can be in any form. Either the signal will be in form of voltage, or signal will be in form of current, signal will be in form of temperature, or it will be in the form of light intensity. All these four can be called as analog signal only. Whenever you are continuous and analog signal into a digital representation, then a microcontroller can understand it, where the digital representation of bits can be only in the form of zeros and ones, where these bits are going to determine the conversion along with the more high precision offerings. And coming to the applications which are presented in ADC: sensor data acquisition, environmental monitoring, audio processing, sensor data acquisition. By using sensors, the data is going to be collected. Most of the sensors are going to output the analog signals, which is essential for sensor data where voltage or current. And coming to environmental monitoring, ADCs, which are going to be used with temperature sensors, which are light sensors or quality sensors, are to convert the real world connections. And also audio processing. In audio applications, ADC is going to convert audio signals from microphones into digital data, which is used for processing, storage, or transmission. These are the things, these are the applications which are used in ADC. And now we are going to know about DAC, which is digital to analog converter. In digital to analog converter, which is going to perform the exact opposite function of ADC. There we are converting the analog signal into digital transmission. That is, whatever the analog signal was, either it was a current, it was a signal, whatever it is going to be converted to zeros and ones. Here the zeros and ones are going to be converted with the help of microcontroller to analog signal, which is, if I transmit a zero, it is going to be converted into analog signal, which will be in the form of voltage or in the form of current. That is what digital to analog converter was. And what are the different applications? The applications in DAC, which is digital to analog converter, was signal control, audio signal generation, industrial automation. Coming to signal control, which is going to be used to control the actuators like motors, speakers, or LEDs by converting the digital control signals for microcontrollers. And coming to audio signal generation, in audio system, DAC is going to convert digital audio data into analog devices for driving speakers or headphones. Industrial automation, DAC are used to control industrial process by converting digital control signals from microcontrollers into analog voltage or current outputs to regulate the wall pumps or other machinery. This is how the applications of DAC was. And now we will see what are the key considerations which has to be kept in mind when we are using this ADC and DAC, analog to digital converter or digital to analog converter in IoT. First key consideration was resolution. Second was sample rating. Third was output voltage or current range. These are the things which we need to consider. Resolution. Here, a high resolution ADCs or DACs, which is going to provide you the conversion between analog and digital signals, which plays very crucial in a high fidelity, which is audio processing. And coming to sampling rate, for the ADCs, the sampling rate is going to be determined by the analog signal into digital signal. And coming to the output, DACs are going to specify output value by the chosen things and with the appropriate signal level. And we need to know about the this particular ADC and DAC in detail. These are the learning resources which might be helpful to you and which might be useful for implementing in our projects also. ADC with Arduino, DAC with Raspberry Pi kit. These are the best tutorials to know more about to the information which I provided. Got guys? And there are n number of kits with microcontrollers are available in market along with this ADC and DAC components, which allows you to perform experiments on signal conversion in a practical setting. By understanding, confidently, I can say a word. By understanding about ADC, analog to digital converter, and digital to analog converter, you are going to gain some experience such as how to implement these in your IoT projects and how AD is going to analog to digital converter is going to allow you to sense and collect information, the analog data, and DAC is enabling you to control actuators and generating analog signals by the digital commands. This is going to empower you guys by creating IoT systems which can monitor, which can analyze, which can interact with the physical environment. This was the beauty of the sensors controlling. And coming to the last topic, which is temperature and humidity sensor, which is DHT11. In this was the sensor which is popular choice for measuring both temperature and humidity in various IoT devices applications. Due to its low cost, understand these things. It was very low in cost. It was very easy to use. The compact size is also very convenient. How this is going to function? Know about this DHT sensor a little bit more. It is a sensor, digital sensor, where digital signal containing both temperature and humidity. Here there are two components for sensing. One is a capacitive humidity sensor, which is going to measure the amount of moisturizer in the air by detecting the changes in capacitance. And coming to the second one, a thermistor, which is going to measure the temperature by detecting the changes in electrical resistance. These are the two components which are existed in DHT11 sensor. And this sensor is having a limited measurement range. Temperature 0 degrees to 50 degrees Celsius only, with an accuracy of plus or minus 2 degrees centigrade. Coming to humidity, 20% to 80% only it can going to sense with an accuracy of plus or minus 5%. And coming to the benefits, by using DHT11, we are going to get low cost, easy to use, digital output, compact size. Low cost, as I told you, it is very highly affordable compared to the other temperature and humidity sensors. Here we are only having 4-pin interface, which is very easy to use and no need of complex analog or digital conversion circuits, and which is ideal space for IoT projects. With this, I can heartfully say that by using this DHT11 in our IoT projects, which is going to be very helpful. Now, have a look how this DHT11 is going to be connected with microcontroller. As I told you, it is having a 4-pin interface, which VCC was power supply. Another was ground connection. Third was data, bidirectional data for communicating with microcontroller. And the fourth one, you need to leave it unconnected. And the a pull-up resistor, which is typically is going to evaluate between 4.7 kilo ohms to 10 kilo ohms, which is connected between a data pin where a power supply is going to be grabbed to you. And how the data has to be read by using the DHT11 sensor, which is going to be a specific start signal, and by using the sensor we are going to transmit the digital signal comparison and humidity data also. Libraries are going to be more helpful in DHT. Why? Because it is going to tell you about Arduino simply specification and data decoding. And what are the applications which are there in DHT11? The first one is environmental monitoring, which is a monitoring temperature where humidity in homes, greenhouses or weather stations for data logging and control purposes. This was the first application, environmental monitoring. Coming to the second one, smart agriculture, open irrigation systems and controlling ventilation in greenhouses based on the real-time temperature and humidity readings. Coming to the third application, smart homes, adjust thermostat settings or trigger dehumidifiers based on the temperature and humidity levels, which are more convenient to us. And coming to the fourth one, IoT wearables for tracking the body temperature, smartwatches, which are mostly used by most of the persons nowadays for monitoring your health applications. And also, what exactly the limitations? Limited measurement range was there, so sampling rate was there, and no external power supply is required for this. These are the different kinds of limitations which are given to DHT11 sensor, which is temperature and humidity sensor. Coming to the first limitation, which is not suitable for the applications which are required for high precision. For extreme temperature and humidity conditions, it is not suitable. And also, there is only slow sampling rate. As I told you, only 1 H, 1 reading per second is going to be calculated. And also, no external power supply is required. Why? Because a microcontroller is provided to provide power which is limited in the form of battery. And what are the alternatives? DHT22 and AM2302. These are the two alternatives for DHT11 sensor. Whereas DHT22, which is going to offer you a wide measurement range and high accuracy compared to the DHT11. Why? Because it is more expensive compared to this. And also here another factor, one is AM2302, which is similar to DHT22, but it is going to provide additional features. And along with that, BME280, which is a combination of temperature, humidity, and along with that pressure sensing. These three comes in a single package, which is ideal for comprehensive environmental monitoring. These are the alternatives for DHT11 sensor. And what are the different other learning resources which might be helpful to you guys? Have a look. DHT11 sensor using Arduino, DHT11 tutorial. These are the two topics from online which are more helpful and which are useful to you for doing your projects. As I told you, there are a number of kits with microcontroller, which includes this DHT11 for a better experiment process for comparing the temperature and humidity in our IoT projects. One thing I can confidently say, if you understand this DHT11 sensor and its application, you are going to create wonders in your IoT projects with a sensitive environmental conditions by allowing the intelligent and responsive systems. That I can confidently say. That's it, guys. This is about the three sensors: voltage sensor, ADC and DAC, analog to digital converter, digital to analog converter, and the last DHT11, which is a combination of temperature and humidity sensor. With this, I can conclude this session. We'll meet in the next session with more number of sensors, how to control those sensors, and what are the different kinds of applications in detail in the next class. Thank you. That's it. I'll meet in the next class.
Like, share and subscribe. Hit the bell icon for more updates.